Okay, so the next question is basically an analysis of monthly wages paid to workers in two firms A and B belonging to the same industry gives the following results. So basically there are two firms A and B. These two firms belong to the same industry. So firm A and firm B belong to the same industry. And then the analysis of monthly wages paid to workers in these two firms A and B happened to be the number of wage earners, the number of wage earners and then mean of monthly wages mean of monthly wages, and then you have the variance of the distribution, of wages, variance of distribution of wages and then you have basically firm A and then you have firm A and firm B here. Firm A and firm B here. So here you have 586, here you have 648, here you have rupees 5,253, here you have rupees 5,253, and then the variance is 100, and over here the variance is 121. Okay, so now basically what we have here is this data, which is basically this firm A and firm B are in the same industry. And this is an analysis of the monthly wages paid to workers in these two firms, well, again, belonging to the same industry. And that we have these results over here. So the number of wage earners over here was 586, which is basically and this is 648 people. And over here I have the mean of monthly wages, which happens to be the same amount, 5,253 and 5,253 rupees, both in rupees, and the variance of the distribution is basically 100 and 121. Now you know that variance is basically the formula for variance is sigma squared, and it's equal to basically 1 over n sigma of f of I x of I minus x bar whole squared as I goes from 1 to n. So now if these observations are related to, so this is the variance of the distribution of wages. That means that these are in That means that these are in rupees. So the unit over here would be, of course, rupees squared, for example. So the unit over here would be rupees squared, rupees squared. So now the questions that we want to answer is which firm A or B pays larger amount as monthly wages, and which firm A or B shows greater variability in individual wages. So now to answer the first question, question number 1, which firm A or B pays larger wages, pays a larger amount as monthly wages. So to figure out which firm A or B pays a larger amount as monthly wages, you see that the mean of the monthly wages for this firm A was 5,253, and this was the number of wage earners in this company, 586 people, and this was the number of wage earners in this firm B, around 648 people. So the mean of the monthly wages happens to be the same. So a larger amount as monthly wages so basically the variance, I think the only way to calculate this is, of course, this would be no definitive answer, but you could with some certainty, because you can see that the mean is the same, right? The mean is the same, and that the variance of the distribution is 100 and 221. So you could, and basically the variance of the data is not very different. So you could with, I don't know, probably with 60-70%, even 80% certainty say that, for example, if you multiply the number of wage earners here by the mean of the monthly by the mean of the monthly wages, you would get some number over here, and do the same thing over here. Whichever number is larger, that means that firm basically pays a larger amount as monthly wages. I suppose that's the way to solve. Otherwise, there is no other way to solve the problem. Let's see where I am over here. 15.3, question number 2. Let's see. Oh, I'm over here. Okay. So I'm actually doing question number 3. I kind of missed question number 2, so we will go to question number 2 after this question. So now question number 3, it says that so an analysis of monthly wages paid to workers in two firms that belong to the same industry gives the same result. Number of wage earners, firm A, firm B, and so on and so forth. And this is question of monthly wages of firm A is equal to 5,253. number of wage earners is in firm A is equal to 586. So the total amount would be 586, and the monthly wages of firm B would be 5,253. Number of wage earners is 648. Thus the firm B pays a larger amount as monthly wages. Okay, in B. Thus the firm B pays the larger amount as monthly wages, as the number of wage earners in firm B are more than the number of wage earners in firm A. Okay, so that's basically the same thing. So you basically, all you need to do is write this properly, rupees and rupees. So basically then the amount paid, for example, you can say the wage or total wage, basically the total wage paid in firm A would be equal to basically 586, the number of wage earners, times the mean of monthly wages, which is, of course, this is not the exact amount of the wage that is paid to these people, because this is the mean of monthly wages, and what that means is that, for example, one wage earner earns more and one wage earner basically earns less, so that's basically the mean of all of those values. But you can kind of take this for a mean value. Of course, you can of course take that for a mean value of all of those values, and then multiply it by the number of wage earners, which is going to give you, for example, 5253 times 586. And of course, since this number is larger than this number, then you can say that in firm B, basically a larger amount is being paid to wage earners, because the mean of monthly wages is the same and the number of wage earners in firm B is higher. So the answer is basically simply firm B. You're not supposed to calculate anything here. Now, the second question is which firm, A or B, shows greater variability in individual wages? Number 2, which firm, A or B, shows greater variability in individual wages? In individual wages. So in order to calculate that, so since the mean of the wages, basically we said that the coefficient of variation is basically sigma over x bar times 100. Now in this case, basically our x bars happen to be the same, 5,253, 5,253. So if the standard deviation is basically, the standard deviation is if the standard deviation is higher, in whichever case the standard deviation is higher, then in that distribution you have higher variability of individual wages, and that happens to be, of course, in firm B. So you don't need to calculate anything. You just Thus, firm B has greater variability in the individual wages. So, and I'm not really interested in the value, for example, because you know that the square root of 121 is greater than, of course, the square root of 100. So the standard deviation over here is higher than the standard deviation here. So you can simply answer the question. Now, question number 2 is another from the prices of shares X and Y below. Find out which is more stable in value. So we have some shares over here, and these shares happen to be, the prices happen to be this way. So you have basically X and Y, and you have 35, 54, 52, 53, and so on and so forth. Okay, so let me write down the values. It's 35, 54, 52, 53, 56, 58, 52, 50, 51, and 49. And you have over here 108, you have 107, you have 105, you have 106, 107, 104, 103, 104, 101, let me see, 108, 107, 105, and yeah, again another 105. Another 105, 106, 107, 104, 103, 104, and 101. Now, I don't really know what sort of data this is. I don't understand this data because I don't know if that's data over time or whatever that is. But let me take a look at the solution here and let me see how they have solved this problem, because otherwise I don't really know what that is. So from the prices of shares X and Y below, find out which is more stable in value. So the answer is the prices of the shares X are basically 50, 35, I see, 54, 52, 53, 56, 58, 52, 50, 51, and 49. The number of observations is 10. The following table is obtained corresponding to shares X. So we have X of I minus X bar. And so the variance, or sigma 1 squared, is equal to 35. Standard deviation is equal to this. Okay. The mean is 51. The mean is 105. Okay. Okay, so these are individual observations, and it seems that it does make sense, although I don't understand really how, but it seems that it does make sense to, because over here, as I can see, the basically the mean over here is 51 for basically these observations X, and the mean over here is 105 for these observations. Still they have gotten two numbers for standard variation, and then they have used these values to calculate basically coefficient of variation, and then it says that coefficient of variation of prices of X is greater than that, so that's the prices of shares Y are more stable than the prices of X. Okay, so what you can do in order to decide which one of these prices are more stable, so again we have to calculate the coefficient of variation here, and the coefficient of variation is nothing but and of course over here, before I start, I have said a couple of times that, probably even 5-6 times, that when the mean of your data is, when the mean of two distributions are not the same, you're not supposed to compare them together. But because you're taking the standard deviation, the ratio of the standard deviation to the mean of the data, it somehow basically, it seems that it does basically, I mean, the algebra is doing the magic. Algebra is always actually doing the magic. The algebra is doing the magic, and so for example, if I take this value for some observation, for example sigma 1 over, for example, x of 1 bar, and if I take this value for sigma 2, for example, divided by x of 2 bar and multiplied by 100 for another observation, and if x of 1 bar is not equal to x of 2 bar, still you can compare these two values together. You can call it C coefficient of variation 1, for example, coefficient of variation 1, and you can call this coefficient of variation 2, and you can still compare basically these two values together. Whichever one is larger, that means that observation, I'm sorry, that set of observations is more variable. Whichever value is smaller, that means that set of observations is more stable. And well, of course, if x of 1 bar is equal to x of 2 bar, then you don't really need to calculate this. Then in case basically sigma 1 is greater than sigma 2, for example, then you can say that, for example, the distribution 1 is more variable than distribution 2, or you can say that distribution 2 is more stable than distribution 1. Okay. So I have to correct myself here, and then now we will basically continue with this example. Okay, so now in order to calculate basically in order to to calculate which of these basically shares. This is a share. These two are basically, these are the prices of basically two different shares, the stock market. So in order to calculate which one was more stable, you need to calculate the coefficient of variation, which is the same thing as basically sigma over basically x bar times 100. So I need to calculate my x bar here, I need to calculate my sigma here and calculate the coefficient of variation, and then compare the two. And you know that basically sigma is standard variation is equal to standard variation, and x bar is the mean of your data. So you already know all of that. So now what I need to do is basically write this data up here. So I take these as my x of i's, and you can see that 35, these are all basically written in, not in ascending order really, so you have to basically move these around a little bit. So if I were to write these in ascending order, I would write this as, for example, 35, and I have no 30 anymore, so I have only one 40 here, which is 49. And then 50 would be 50, 51, 52, 53, 50, 51. So 50, 51, and then 52 I have twice. 52 I have twice. And basically 53, 54, 53, 54, and 56 and 58. 56 and 58. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6. 6 and plus 4 is equal to 10. So now I can write this data as follows. I can write these as my x of i's, and I can write this as f of I, the frequency of this data, and I can write all of these in this table, which is 35, 49, 50, 51, 52, and I don't repeat 52, I just write twice here, and 53, 54, 53, 54, 56, and 58. And all of these, the frequency of all of these is 1, 1, 1, and so on and so forth. So that is my data. And now I need to calculate x of bar. So, or not x of bar, but actually x bar, which is the mean of the data. So my x bar over here is going to be equal to, I can use basically, let's not use the shortcut method. So your x bar is equal to sigma f of I x of I divided by sigma f of I. So if I calculate f of I times x of I, what I will get is basically 35, 49, 50, 51, 2 times 2 is 104, 53, 54, 56, and 58. And so sigma f of I x of I is equal to all of these numbers added together. So the numbers added together would be 35, 49, 50, and 51 would be 101. 104 plus 53 would be 157. 157, that would be 110, and this is 58. If I add all of these numbers together, I get 14, 15, 15 plus 7 is equal to 22, and 30, and I have a 3 here, 6 plus 4 is equal to 10, 10 plus 11 is equal to 21, 2, 3, 4, 5. 510. Just to make sure that I haven't made any mistakes here in this calculation. I'm sure I haven't, but let's check. So 35 plus 49 plus 50 plus 51 plus 104 plus 53 plus 54 plus 56 plus 58 is equal to 510 exactly. And I know that sigma f of I here, sigma f of I here is equal to 1, 1, 1, and so 1, 2, 3, 4, 6, 7, 8, 9, and 10. Now x bar is equal to sigma, x bar is equal to basically sigma f of I x of I over sigma f of I, which is equal to 510 over 10, which is equal to 51. So x bar is equal to 51 in this case. Now, what I need to calculate is standard variation, because I'm looking for the coefficient of variation, and that is the same thing as standard variation by x bar times 100. So I need my standard variation. To calculate my standard variation, I need to calculate variance, and then from that I can calculate standard variation. So variance is nothing but sigma squared, which is basically 1 over n sigma f of I times x of I minus x bar whole squared, as I goes from 1 to n. So I need to calculate all the x of I minus x bars related to these observations. So I calculate x of I minus x bar and square it. So now, for example, 35 minus 51 is equal to 51 minus 35 is equal to 4 and 11, so that's 6 and 1, 16. So that's negative 16. So that means that 35 minus 51 is equal to negative 16. And negative 16 squared is equal to some number. And I don't want to calculate actually all of these numbers. I'm actually going to use the shortcut method, because it's too much trouble and it's not really necessary. So as long as you don't understand, for example, as long as you understand what variance and standard deviation are, then you don't really need to do it. You can just use the shortcut method to get to standard deviation. And standard deviation by the shortcut method is basically very simple. It's equal to sigma of x is equal to h over n, the square root of n times sigma of f of I y of I squared, as I goes from 1 to n, minus sigma f of I y of I whole squared, and take the square root of this whole thing. That becomes the standard variation of these observations. So the only thing that I need here I actually need a couple of things, but the calculation will be much more straightforward, not dealing with squaring things and that sort of thing. So for example, I need f of y squared. In order to calculate that, I need f of y of I squared. In order to calculate that, I need y of I. To calculate y of I, we defined y of I as x of I minus a over h. A is the assumed mean of the data, h is the class size. Now I'm going to have to take h as 1 because I have no class size here, and there is no number basically that I can find that all of these numbers are divisible by, so I'm just going to take this as 1, because if I take this as 1, then all of these numbers are going to be divisible by 1, so I can take care of the problem that way. So I'm going to take my h as 1, and I'm going to assume mean of the data as, for example, 52. A is equal to 52. And so y of I is going to be equal to x of I minus a divided by h, and h is equal to 1, so you don't need to worry about that. So that's really only x of I minus a. So x of I minus a is equal to, for example, 35 minus 52, 49 minus 52, 50, and so on and so forth. So 35 minus 52 is equal to 52, 35, and then you have 4, 12, and basically 7, 17, negative 17, for example. 49 minus 52 is equal to negative 3. 50 minus 52 is negative 2, negative 1, 0, 1, 2, and 4, and 6. You see, it's very easy to calculate, although you might spend probably pretty much the same amount of time on calculation, but your numbers are going to be much more straightforward. It's not weird numbers, for example, 35 minus, for example, 78. No, not this number, but for example, minus, for example, 153. This is a weird kind of calculation. You have to write it backwards, and then it's not really not the best calculation that you would ever do. So these are your y of i's. Now I need to get my x bar. I'm sorry, the x bar I have already calculated. So I need to calculate f of I times y of I squared. F of I times y of I squared. So y of I squared is going to be, for example, equal to negative 17 squared times 1. So 17 squared, these are the kind of numbers that you need to know. So we will make a list of these numbers, and then we will put them on some list, and then we will use them over and over again. Because there is no way to know them, and you have to calculate them every time like this, and it's not easy to use a calculator to every time write, for example, 17 times 17. You have to know that, 289, right? So this you need to know. So basically it's not really about any list or anything. You just go from 1 squared, 2 squared, 3 squared, 4 squared, and all the way up to, for example, 25 squared. Memorize all of these. And you go from 1 cube, 2 cube, 3 cube, and go all the way up to, for example, I don't know, 15 cube. 15 cube is probably something about 3,375. That not that large a number, and you do need it anyway. So you do need to make this table for yourself and write these numbers down a couple of times so that you may learn them or memorize them, like the way that you learned, for example, multiplication table in elementary school, for example, something like that. It's necessary. So now, for example, 289 times, for example, 1 is equal to 289. 3 squared is equal to 9, so that's a 9. 4 times 1 is equal to 4. 1 times 1 is equal to 1, 0, 1, 4, and 16, and 36. So I'm going to make a note here for myself after this video to do the same thing for myself as well, of course. And then sigma f of y of y squared is equal to all of these numbers added together, which is basically, this is 13, 14, 15, 19. So that's 19 plus 16 plus 36 plus 289. So that's 12. 12 plus 18 is equal to 30. 11, 12, 13, 16, 1, and 360. That is equal to 360. Now let me do this calculation once on a calculator, so I haven't made any mistakes. 289 plus 13, 14, 15, 19, 16, 36 is 360. Okay. The next thing that I need here is f of I y of I. F of I y of I, because I need f of I y of I sigma f of I y of I, which is basically negative 17, negative 3, negative 2, and negative 1, 0, 0, 1, 2, 4, and 6. 1, 2, 4, and 6. And sigma f of I y of I is all of these numbers added together. That's basically 10. 10 plus is equal to 13, positive. And then you have 5, 6, 6 plus 17 is equal to 23, so that's negative 23. And if you subtract, you will get 0, so that's negative 10. That is negative 10. So I have basically 10 plus 3 is equal to 13 minus 5, 6 minus 17 is equal to negative 10. So now I can put everything in this formula. I can write this as h, which is equal to, which we took as 1, and nv is basically sigma f of I, which is equal to 10, which is times the square root of 10 times sigma f of I y of I squared is equal to 360 minus sigma f of I y of I squared, which is equal to 100. So now to do this calculation, you have basically 1 over 10 times basically 10 times 3, 360 is 3,600 minus 100 is equal to 3,500. And the square root of 3,500 is equal to 3500. Okay, so 5 times 5 is equal to 25. 6 times 6 would be 36 now. So 10 and 0, 5 plus 5 is equal to 10. 1 digit here, 1 digit here, and then 10 times 100, I don't know, 10 times 101, 100, 105 times 5 is equal to 108 times, it's 109 times 9 is equal to 109 times 9 is equal to 981. 981. Okay, so 9 and 9, 981. If you subtract, you will get 980, and 1000 would be 20, so that's 19. 0, 0, 0, 0. 109 plus 9 is equal to 109 plus 9 is equal to 18. 118, I'm sorry, 118. Basically one digit here, one digit here. And you're looking for 118. And that's around 1,200. If I go 2 times, 2,400, which is not, so 1 time, so 181. And you can go for 8, 9, and 10, 9, 1, and 7. And then another 2 zeros you can add here as well. 0, 0. 1181 plus 1 is 1182. Is 1182. Another digit here, another digit here. You're looking for 72,000. 72,000. So 72,000, and this is 12,000. 72,000, and this is 12,000. So that's that you can simplify, and 72 divided by 12 is equal to 636, and that's around 6 times. So 6 times would be 1182. 6 times 6 is equal to 6 and 1, 2, 3, 4 zeros. 6 and 3 zeros. 48 and 2 zeros. 12 and 1 zero. And then you have 36. So you have a 6 here. You have a 5 here. You have a 9 here. You have a 0, 1, and 7. That's 70,956. So that's 6 times. And 6, 7 is 70956. So you have 0, 18, 9, and 10. 4 and, well, 4 and, actually we don't have to do this anymore, 0 and 0. But basically the answer is here is 59.2. Is 59.2 divided by 10, which is equal to 5.92. Is equal to 5.92. So 5.92 is the standard deviation of your data related to the share X. Is 5.92. Let me see if the answer is correct. Which question was that? Question number 2. Question number 2 is 5.91. Take it as 5.92, it's okay. That is your standard deviation related to share X. Now we do need to do the same thing for basically share Y, and we don't have, of course, no space here, so I'm going to go up here and now the share Y, I'm going to basically write the data over here. So basically the data that I had was basically something like this. It was basically Y, and then we had 100, 800, 705, 100, 800, 705, 105, 106, 2 times 105, then 106, 107, 104, 107, 104, 103, 104, and 101. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The same number of data, 3, 6, and 4, 10. Okay, so the data that I have goes from 103 to, so I can write my data this way. Basically, I can take all of these as x of I, starting from 103, which occurs one time. Actually, the 101 is also there. 101 is also there. Then you have 103, and then you have 104, basically 2 times. 104 2 times, and this is 1 time. And then you have 105 2 times. 106 1 time. 106 1 time, 107 2 times, 107 2 times, and 108 1 time. So you have basically 2, 4, 6, 8, and 10. That is your data. And so you have your f of I over here. And we need to now do the same thing for this data, and I'm going to just simply use the shortcut method. Okay, so now I need to calculate basically x bar. I need to use the shortcut method to calculate x bar and sigma here. Divide sigma by x bar to calculate the coefficient of variation. So, and basically the shortcut method is the best way to do this. So using the shortcut method, we said that basically x bar is equal to a plus h times y bar. I need my y bar here, and also we said that basically sigma of x is equal to h over n times the square root of n times sigma of f of I y of I squared, as I goes from 1 to n, minus sigma of f of I y of I whole squared, and then raise that to the, basically take the square root of that. That would be sigma of x. Divide that by x and multiply by 100. You will get your coefficient of variation. Now, in order to do that, I need to calculate x bar. I need y bar, and basically to calculate y bar, I need y of I. And we said that y of I was equal to basically x of I minus a over h. Now over here again, I have no class sizes, meaning that I have no classes, so I have no class size. I'm going to take my h as 1. And I'm going to take a as, for example, this value here. I'm going to take this as the assumed mean of the data. So that means that then if h is equal to 1, then y of I is simply going to be equal to x of I minus a. It's simply going to be equal to x of I minus a, which is basically 101 minus 105 is equal to negative 4. 103 minus 105 is equal to negative 2, negative 1 and 0, and then you have 1 and 2 and 3 here. And so that is my y of I. Now to calculate y bar based on this, you know that y bar is equal to sigma f of I y of I divided by sigma f of I. So if I calculate sigma, basically f of I times y of I, what I will get is basically negative 4, negative 2, negative 2, 0, 1, 4, and 3. And sigma f of I y of I is equal to basically 7, 8. So you have 8 over there, and then you have a negative 4 and negative 8 here, so that's a 0. So that's 8, and then this is 4, so that's a 0. That means that your y bar is equal to 0. Now if y bar is equal to 0, then if y bar is equal to 0, then x bar is equal to a, meaning that the assumed mean is actually the mean of the data. And so x bar is equal to 105. So that's about my x bar. Now the next thing that we have here is calculating the standard deviation, for which you need, basically we have already calculated this part, sigma f of I y of I over here, and sigma f of I y of I squared, I need to calculate it. So f of I y of I squared, basically that's a 16. That's 4 times 1 is equal to 4. That's 1 times 2 is equal to 2. That's a 0, 1. 4 times 2 is equal to 8. And 9 times 1 is equal to 9. And so sigma f of I y of I squared is equal to, that's a 20, 22, 23. 23 plus 17 is equal to, that's 40. Is equal to 40. So what that means is that then I can write sigma of x is equal to h, which we took as 1, and we took h as 1, and n was basically equal to sigma f of I. Sigma f of I was equal to, what happened to sigma f of I? It seems we didn't need it for whatever reason. So sigma f of I is equal to 1, basically 4, 6, 8, and 10. So, okay, it seems that n is equal to sigma f of I is equal to 10, and that's equal to n as well. So that's 1/10. The square root of 10 times sigma f of I y of I squared is equal to 40 minus, and this was 0. So that's basically 400, the square root of 400. That's 1/10, the square root of 400. And the square root of 400, you can write it as, the square root of 400, you can write it as the square root of 4 times 100. Which is the same thing as the square root of 4 times the square root of 100, which is equal to 2 times 10, which is equal to 20. So that's 20 over 10 actually, not 100. 20 divided by 10, which is equal to 2. So sigma of x is equal to 2 here. So as you can see, the value of sigma previously, as we calculated, was something like oh, sorry, we still need to do something else over there. We need to calculate the coefficient of variation. So the coefficient of variation is equal to basically sigma over x bar times 100, which is equal to basically 2 divided by x bar, which is, your x bar was 105 times 100. So divide by, for example, divide by 5, you will get 20 times 5 is equal to 100, and then divide by 5 is equal to 105 divided by 5 is equal to 21. And that's 40 times 40 divided by 21. 40 divided by 21 is equal to 1. So that's basically 19. 190, and then you have is 1 over here, and then you have 8, 9. So 8 times 1 is equal to 8, 1668. So there you have 8 and 10, 2, 2, 0, 0, and then 9 times 21 is equal to, so I take this as 1.9. 1.9. So the coefficient of variation over here is equal to 1.9. The coefficient of variation which we calculated previously was 5.92. 5.92. So this is the coefficient of variation 1 was 5.92. The coefficient of variation 2 is 1.9. CV basically 2 is equal to 1.9. And that means that basically then you can say that the share Y was more stable. Let me take a look at the answer here. Share Y was more stable, and as far as the answers are concerned, they were basically 5.91 and okay, 1.9. We said that the coefficient of variation shares Y is sigma 2 divided by Y bar times 100 is equal to 2 divided by 105 times 100. 2 divided by 105 times 100, 1.9. Okay, so they have actually on the website, on this website here, it seems that sometimes you find some mistakes. But well, of course, it's overall, I mean, you can catch the mistakes. It's not like it would mislead you or anything. For example, as you can see here, the answer over here, it says that, so the coefficient of variation of shares y is equal to sigma 2 by y bar times 100, which is equal to 2 divided by 105 times 100, and that is 1.9, which is equal to 11.58, which is nonsense here. This doesn't make any sense. They have made a mistake here, but anyway, the answer is, this part is correct, and you can tell where they have made mistakes. So it says that the coefficient of variation of prices of shares X is greater than the coefficient of variation of prices of shares Y. Thus, the prices of shares Y are more stable than the prices of shares X. So that's basically that. So we already did question number 3, and so let's see what is question number 4. We have 2 more questions left here from these exercises. We will do them, I don't know, probably in the next video, and then we will continue. See you in the next video.